Hello everyone. Today I am going to explain to you very important theorem, that is basic proportionality theorem in triangles. So let us see what is basic proportionality theorem. It explains about a triangle. In a triangle, if a line is drawn parallel to one side, intersecting other two sides in two distinct points, then other two sides are given in the same ratio. What it means, in a triangle, if we draw a line parallel to one side, then that line divides other two sides in same ratio. So now here DE is parallel to BC, then DE divides AB and AC in the same ratio. That means what? It will divide AB in AB and AC such that AD by DB is equal to AE by AC. So that is the theorem proof. So how to prove it? We write first given. So what is given here? Given we can write from statement only in a triangle. Here we are taking the triangle ABC. So in a triangle ABC, great. In a triangle ABC. In a triangle. So which triangle we are taking here? ABC we are taking. So in a triangle ABC, a line is drawn parallel to one side intersecting other two sides in two distinct points. So that line is intersecting two sides in two distinct points. So we write it as, here our line is DE. So here DE is intersecting AB and AC, AB and AC at B and E respectively. B and E respectively. Means what? It is intersecting AB at D and AC at E such that, how it is intersecting AB and AC such that DE is parallel to BC. So this is what given. So here, our line is DE. DE is intersecting AB at D and AC at E such that DE is parallel to BC. This is what given. Then what we have to prove here? We have to prove that second part. It divides other two sides in the same ratio. It divides other two sides in the same ratio means what we have to do? We have to prove that AD by DB is equal to AE by AC. This we have to prove. This we have to. So to prove this, we need to do one construction. We have to do some changes in the figure. What constructions we have to do? We have to draw a line perpendicular to, we are drawing a line perpendicular to AB through E. So that is EF. We are drawing EF. We are drawing EF perpendicular to AB. And we also draw one more line perpendicular to AC. That is DG perpendicular to AC. This is first point. What we are drawing EF perpendicular to AB and DG perpendicular to AC. Why we are doing this construction again we will discuss later. So this is one part, and another point, we should also join CD and B. Join CD and B. So this is what our construction. This construction we have done. So after we are doing construction, what we did, we have read here. What we did here, one, draw EF. We have done EF perpendicular to AB comma BG perpendicular to AC. And we also join CD comma B. This is what construction. Then after that we will do proof. This is main part in the solution. What we do proof. Now we have to prove that other two sides in the other two sides are divided in the same ratio. So finally we have to show that AD by DB is equal to AE by EC. So for that what we do, we take area of triangle ADE. We want AD by DB, so we will take one triangle ADE and one more triangle area of triangle DBE. So why we have to select these two triangles only? Because we want AD by DB. So to get AD by DB, we will take ADE by DBE. We will take the triangles ADE, area of triangle ADE by area of triangle DBE. If you see ADE, we have triangle ADE like this. This is ADE, and in this ADE, we have EF like this. This is F, this is E. So here, what this is base of the triangle, and this is height of the triangle. Generally, what is the area of a triangle? Half into base into height. So here, for this triangle area, we will get the half into AD into EF. Half into AD into EF because AD is base and EF is height. So area of triangle AD can be written as half into AD into EF by half into we have DBE. DBE triangle if you observe, triangle is there like this. This is DBE. In this DBE, this is D, this is E, this is B. So like this we have. So here base we will take it as DB. This is base. And what is height? You know, height is EF. Like this you can observe in the figure. EF is 90 degrees here. So you may have doubt why height is outside. Because it is accused angle triangle. For accused angle triangle, height will be outside the triangle. So that's why EF is the height for both ADE and DBE. Height is same. So now when you find area of triangle BBE, base is DB and height is EF. So here it is half into DB into EF. So here what happens? Half of will be cancelled, EF will be cancelled, then we get AD by DB. Let us take it as one. Now we have to find one more in the same way. That is area of triangle. Let us write here. That is area of triangle. Area of triangle. We want AE and EC. So AED. We have to take area of triangle AED by area of triangle ECD. So how to why we have to directly select these two triangles only because we can observe here also again we want AE and EC. So we will take AED ECD. Here ADE DBE. Here AED ECD. So like that we will take two triangles. So here same way in this triangle AE is base and BG is perpendicular. So BG is height. So AED is what half of base is what AE and height is what? Height is what BG. So BG by again downward is again half of base is EC now because it is ECD, base is EC, but height is BG. As I said, accused angle triangle how lies outside, height lies outside. So here BG is outside. So EC into DG. So here what happens again half of will be cancelled, DG will be cancelled, we get A by This is what. Now we got 1 and 2. So in 1 we got AD by dB, in 2 we got AE by EC. Now how can we say that AD by dB is equal to AE by EC? If LHS side these two ratios are equal, RHS side also we can say AD by dB is equal to AE by EC. So now we will compare LHS side. In the numerator here we have A of triangle ADE, here in the numerator AED. If you observe, ADE and AED are same. They are same triangle, one triangle. So A line same. Come down. Denominators. It is DBE, it is ECD. They look different. But there is a concept. Whenever triangles are lying between parallel lines and on the common base. See here, these two are the two triangles we have. This is DBE and this is ECD. Now these two are lying between parallel lines. They are lying between parallel lines and a common base. This is what for both it is having same sides, common base. So areas of triangles lying between parallel lines and on the common base are equal. So based on that concept, area of triangle AD is equal to area of triangle DB is equal to area of triangle ECD. Now we write here area of triangle A that is not that is G. Area of triangle DBA is equal to area of triangle ACD. Why? Because we have a concept areas of triangles lying lying between parallel lines and on common base are equal. That's why these two areas are equal. And already numerators are equal. So numerators are equal, now denominators are equal. Therefore, from 1 and 2, we can say AD by BB is equal to A by C. Hence proof. This is the proof of basic proportionality theorem. It's very important. State and proof. Question will come like state and proof basic proportionality theorem. Or sometimes they will give you statement directly prove that a line drawn parallel to one side intersecting other two sides. Prove that a line drawn parallel to one side intersecting other two sides in two distinct points, then it divides other two sides in the same ratio. But they ask you to prove that is nothing but basic proportionality only. In this way you have to prove. Now we have one more that is converse of basic proportionality theorem. Now let us see how to prove converse of a basic proportionality theorem. So this is converse. Converse means what? Before, if it is parallel, the line is parallel, it divides other two sides in the same ratio. Now, here in the converse, if it is dividing two sides in the same ratio, then the line is parallel to third side. So opposite. If it is parallel, it divides two sides in the same ratio. If it is dividing two sides in the same ratio, then it is parallel to third side. So we have to prove converse here. So here also first we write given. What is given here? In a triangle. In this triangle? ABC. So in a triangle ABC, what we know? B is intersecting ABC. B is intersecting AB at D and AC at E. How it is intersecting? Such that it is dividing two sides in the same ratio. So we write AB at D and AC at E such that AD by BB is equal to AD by AC. So what is the difference here? Previously we were having here D is parallel to BC. Now we are having, it is dividing the other two sides in the same ratio, that is AD by BD is equal to AE by BC. This we have. This is given now. Now what we have to prove? RPP. We have to prove that D is parallel to BC. So before D is parallel to BC is given, we have to prove AD by DB is equal to A by C. So AD by DB is equal to A by C is given, we have to prove D is parallel to BC. Now we write proof, no construction is required here. What we do in proof, we will assume wrong. Like in chapter 1, prove that root 2 is irrational. Then what we let us assume root 2 is a rational, opposite we take. So here also we will assume D is not parallel to BC. So let us assume D is not parallel to BC. We will take D is not parallel to BC. If D is not parallel to BC, there can be another line which is parallel to BC. So we write here, then there exists another line. Also, then there exists another line. What BF is parallel to BC. So we assume B is not parallel to BC. Then we will take another line parallel to BC. BF is parallel to BC. So we write here like this. We draw one more line. Like this, we draw one more line, and we assume this is parallel to this. You may have confusion. It's not looking parallel to this. DF is not looking parallel to this, but we assume DE is not parallel to this. So, now according to our assumption, DF is only parallel to this, DE is not parallel to this. Now, because DF is parallel to BC, what we can write? Therefore, we can write because it is parallel to BC. From basic proportional theorem, we can write AD by BB is equal to DF by FC. Why we are writing this? Because it has parallel. DF we took parallel to BC. So AD by DB is equal to AF by FC. This is from by BB, this proportionality theorem. But what we know from given, we know that AD by BB is equal to, we know AE by AC. This we know from given. This is from given 2. So from 1 and 2, LHS side equal we have. AD by D is equal to AD by D. So here from 1 and 2, what we can write? Therefore, from 1 and 2, we can write DF, we can write, oh, I have written here wrong. This is not DF, this is AF by FC. This. So this is AF by FC. So AD by DB is equal to AF by FC from basic proportional given. AD by DB is equal to AE by AC from given. So now from 1 and 2, what we can write? AF by FC is equal to AE by AC. So what I do, I add 1 on both the sides. Add 1 on both sides. And what we get here? AF by FC plus 1 is equal to AE by AC plus 1. Then what we get? AF after taking LCM, AF plus FC by FC is equal to AE plus EC by EC. Now what it is AF plus FC? AF plus FC is AC. So it is what? AC by FC is equal to AC by EC. Now what happens? AC we can cancel. So finally we get therefore FC is equal to AC. We got FC is equal to EC. Is it possible FC and EC equal? FC and if and E are different. When if and E are different, FC is not equal to EC. But we got FC is equal to EC. What it indicates? So this is possible. FC is equal to EC is possible. Right? This is possible. This is possible only when F and E coincide each other. But F and E are not different point, they are it is a single point. FC and EC will be equal only when F and E are a single point. So if F and E are single point, then taken DF is parallel to BC. That means what? There will be only one line. BE is parallel to BC such that it divides other two sides in same ratio. If it divides other two sides in same ratio, then what it means? BE is parallel to BC. B is parallel to BC because BF is parallel to BC. Now F is equal to E only. Then only FC and BC are equal. So B is parallel to BC. So now onwards, you have to remember this. There will be problem based on this converse of basic proportionality theorem and basic proportionality theorem. According to basic proportionality theorem, if line is parallel, it divides other two sides in the same ratio. From converse, if a line is divided in two sides in the same ratio, then it is parallel to third side. Hope this video will help you to understand the theorem proofs and also solve the problems related to BPD and converse of BPD. Thank you.